conversations. You guys want to give it a shot?
Yeah, wait, what is this?
So, I have two very...
What's your name?
My name is William, by the way.
William? Sean, nice to meet you.
Hi, I'm William. Nice to meet you. So, I have two
What's
very...
in the jar?
Oh, yeah, thank you, yeah. Well,
I see,
it's about what I'm going to present here, but... You guys want to give it a shot?
Sure.
Yeah? All right, hell yeah. All right, so two very easy questions just to see if you guys trust your common sense.
Okay.
Yeah, so... You guys want to give it a shot?
I don't trust my common sense, though. All right,
Well, we'll find out if you do or not.
I trust my common sense.
Yeah? There's two very easy questions to see if you do trust your common sense. All right, so we'll start with this one.
Oh.
Okay. This one. All right, so there's 3 box trucks here, and they're completely sealed. They are all on a level surface. The only difference between these, obviously there's an apple hanging from a string as well, and all 3 of them. The only difference between these 3 box trucks is that one is at rest, one is accelerating forward, and one is accelerating in reverse. So out of these 3, which one is at rest? Yes. Yeah. So how do you know that one's at rest?
Because the ball's in the middle.
Yeah, it's not moving. You could say that.
Yeah.
It's staying vertical.
Yeah.
You could say that. So which one's accelerating forward?
That one there.
Yes. How do you know?
Because the ball's moving back, which would be... Because we should know this.
Because the lorry's accelerating, the ball still hasn't had time to accelerate.
Yeah, because of inertia.
Yeah.
So until the string's able to pull the until that moment, then it's gonna appear to swing back. It's gonna
stay in the same place until it...
Yes, you got it. Perfect. All right. So that was the first one. Pretty easy.
Yeah.
So here I have a box truck. So 3 different box trucks, and there's an apple hanging from a string inside of it. Another thing to note is that all of these box trucks are on a level surface. The only difference between these 3 box trucks is that one is at rest, one is accelerating forward, and one is accelerating in reverse. So out of these 3, which one is at rest?
You got it? I got it. Can I say the same thing?
Nah, you say it first.
B. Yes, it is B. So why would you say B?
Why would I say B? Well, just general physics principles on
Yes.
vectors.
Example, yeah.
But it depends. You also said, I'm assuming you're giving me a priori like system. So, like you said,
They're all on a level surface. Yes, because somebody said that this could be at rest on a hill, which is true.
Yeah.
Yeah.
And
So that's why I have to say.
I'm also assuming that there's no friction.
Yeah. Okay.
Or air resistance. So like you're
Yeah.
dealing with a vacuum.
Another thing, obviously, the box is completely sealed. Like I said. Yeah.
So it's like you're dealing with like a vacuum. So yeah.
Yeah, so obviously, and the reason is because the ball is not swinging in any direction. So the apple's not moving in any direction.
Yeah.
Therefore, obviously, this is the one at rest. It's not moving, right? So out of these 2, then A and C, which one's accelerating forward?
This one's
Yes. So how do you know that one's accelerating forward?
same thing. Like looking in a vector in a vacuum.
Yeah. So it has to do with inertia.
Yes.
Yeah. So obviously, the resistance to change.
Is that what Newton's second law?
Yeah, it's the first law.
First law?
Yeah. So obviously, an object at rest will stay at rest unless there's a force acting on it. So obviously, the force of the truck pushing in this direction, obviously, this is able to resist that force, and it just remains in this position.
Yeah.
So it appears to swing back.
Is this going to be like a representation of the brain in CTE or something?
It'll be a representation of what I'm asking. Here, I have 3 box trucks, and it's completely sealed, right? There's an apple hanging from a string in all 3 of them, and they're all on a level surface, right? The only difference between these 3 box trucks is that one is at rest, one is accelerating forward, and one is accelerating in reverse. So out of these 3, which one is at rest? Yes, you got it. Why is that one at rest? Exactly, pretty easy, right? So which one's accelerating forward?
This one.
Yes. How do you guys know that one's accelerating forward?
It's like
When you accelerate,
when you accelerate, it goes back.
Yeah, because of inertia.
Yeah.
So the whole truck is moving forward, but the apple appears to swing back, which is being left behind.
Sure, yeah.
Right? All right, cool. That's the first one, pretty easy. Second one, pretty similar, but instead of an apple, it's a helium balloon.
Okay.
Same thing, but out of these 3, which one is at rest?
B.
Okay, yes, for the same reason as the first one. Which one's accelerating forward?
A, yeah.
It's actually C in this one.
Is it?
Yeah, and the reason why is because obviously air is more dense than helium. So when you accelerate the box truck in this direction, for example, all of the air that's inside of the box truck is also being pushed in that direction through space. And because air is more dense than helium, it's able to push it in that same direction.
That's it.
So it reacts in the direction of a force. That's what we call buoyancy. When something less dense is pushed by the medium that surrounds it, right? The second one, the second one's pretty similar, but instead of an apple, is a helium balloon. So same thing. Out of these 3, which one is at rest?
That one.
Yes, and it's for the same reason as the first one, because it's vertical. which one's accelerating forward?
Oh,
Which one would you say? Yeah, so it's actually C in this one.
what?
Yes. So air is more dense than helium, right?
Oh.
Yes. So when you accelerate the truck in this direction, the air that's inside it,
Fine, fine.
the air pushes it because the air is also being pushed through space in that direction because it's inside the truck.
Oh, wow.
So
Okay.
so this one is pretty similar, but instead of an apple, it's a helium balloon inside the truck. So out of these three, which one is at rest?
This one's at rest.
Yes.
This one's forward. And this one
Reverse. Okay, this one is actually reversed, and this one's actually.
Oh, that's right. It's density.
Density
Yeah, yeah,
differences. So in this scenario, obviously helium is less dense than air.
Yeah.
So when you apply a force in this direction, all of the air that's inside of the box truck is also being pushed in that same direction through space. So because air is more dense than helium, is able to push the less dense object in that same direction. So again, that's what we will call buoyancy. It's when a less dense object gets pushed by the medium that's around it in a particular direction. In this case, being this direction, right? So, and I can demonstrate that here. Like this is an accelerometer. It's a buoyant object inside of water. So obviously, water is more dense than this red ball. So if I accelerate in this direction, what do you think the ball is going to go? Yes, it's going to go with the direction of the force because water is more dense than helium.
And that's
right?
assuming constant momentum, right?
Well, acceleration.
Yeah.
Talking about acceleration. Yes, exactly. So I can demonstrate that here. Look, this is a buoyant ball inside of water. Water is more dense, obviously. So if I accelerate in this direction, what direction do you think the ball's going to go? Yes.
Yeah.
See, it's pushing the direction of the force. So that's what we'll call buoyancy. Exactly. So this is a buoyant object. So that's what we'll call buoyancy.
Yeah.
So obviously, that water is more dense than this ball. If I accelerate in this direction, what direction do you think the ball's going to swing or move?
Wait, sorry, say that again?
So this is a buoyant object. I can demonstrate these physics here.
Yeah, let's do it.
So
So then in the same logic, the
ball should get pushed in that direction.
Interesting.
Yeah, so that's what we would call buoyancy. When something that's less dense than the medium that surrounds it gets pushed by that medium, right? So,
Learn something new every day.
yeah, I actually didn't know that either until a few years ago. So here's the thing. I did
When
this
something serious happens, you'll see.
I did this experiment myself inside of a cargo van with a helium balloon and an apple. So based on these principles, what direction did I accelerate here? To the right or to the left?
Oh, I can't really see.
There you go.
Oh, that's much better.
So the helium went that way?
Yeah, there you go. You see the helium balloon?
It's going that way.
Yeah.
Yes. So what direction did I accelerate this container? To the right or to the left?
To the right.
Yes, exactly. Because not only does matter show you when there's a force applied, it shows you the direction of the force, especially if you have a buoyant object inside.
Yeah.
The buoyant object will always get pushed in the same direction as the force, right? And then, real quick, I did it with different states of matter. So I did it in a water container with a steel ball and a ping pong ball. So right here, did it accelerate to the right or to the left? Yeah, to the left, because that's the direction the buoyant object got. The steel ball appeared to move in the opposite direction. That's because it was being left behind. And the camera was also moving with the container. And that's why the steel ball only appears to go back.
And the other one goes up.
Yeah, and the other one goes forward. Perfect. Dude, I did this experiment with the apple and a helium balloon inside of a box truck myself, and I want to see if you guys can tell what direction I accelerated. Here it is.
Is this for like some like?
It's a you could say, kind of, you could say that. I know this the brightness is a little low here, but can you see the helium balloon and the apple hanging?
Yeah.
Did I accelerate to the right or to the left?
That way.
Yes, exactly, because obviously the helium balloon reacted to that push, right? So another thing is basically matter will always react to acceleration, you know? And again, I did it in a smaller scale with different states of matter. So a ping pong ball inside of water that's buoyant and then a steel ball that's hanging. So in this scenario, what direction did I accelerate? To the right or to the left? Yes, exactly, because the buoyant follows the direction of the force. So here, let me just show you this real quick. I did this apple and helium balloon experiment in a cargo van myself. And based on the principles, what direction did I accelerate here? To the right or to the left?
To the right.
Yes, you got it. Yeah. So matter will always react to acceleration. Not only that, you'll be able to tell what direction that force is because of the buoyant object.
Got it.
Right? So here, I did it in a smaller scale just to prove the point. Again, a container filled with water and a ping pong ball and a steel ball.
I see.
So what direction did I accelerate here? Exactly. Yeah. Again, matter doesn't lie. Reality doesn't lie. You know.
Yeah,
So
yeah.
it shows you. So here's one last one.
Okay.
So I was holding a water bottle like this at rest, and I accelerated one down vertically. So one was accelerated down. So out of these two, which one would you say I accelerated down from being at rest? The one on the left or the one on the right? Vertically.
The one on the right?
Yes.
Yeah.
Yeah. Well, that one actually shows the reaction.
Yeah,
It shows
exactly,
the pressure.
yeah.
You know, that water. You know, the water pushing the ping pong ball down. So here's the thing: if I was holding it at rest like this and I just released it into free fall, do you guys believe gravity pulled it down?
Yeah.
Yeah, right. You guys believe gravity accelerated down. So here's the thing: the one on the left was actually free fall, but we see that matter didn't react to that acceleration. And I don't know if you guys knew, gravity is just a theory. So a pulling force of gravity has never been measured or detected. So again, that's why Einstein came out with his theory of relativity, just to explain how objects are accelerating down in free fall with no effects of acceleration. But the reality is because objects don't accelerate down in free fall.
Right.
So,
Oh, thank you.
yeah. So last one, and then
Which,
and
but then
then
how
we're
does
done.
so how does this question link with this? Then?
Well, this is common sense. Now, if you see a buoyant object moving in any particular direction,
Yeah.
you know that it's being pushed in that direction by the medium.
Okay.
So that's common sense now. From now
Yeah,
on. Yeah. So here, I was holding a water bottle like this,
Yeah.
but I only accelerated one down vertically.
Yes.
Out of these two, which one did I accelerate it down vertically? The one on the left or the one on the right? If you had to pick.
Wait, what were you pushing down?
So the water bottle,
Yeah.
it has a steel ball and a ping pong ball inside.
Okay.
And I was holding it like this,
Yeah.
but I only accelerated one down like this vertically.
Okay. You
Out
only.
of these two, which one would you say I accelerated down?
Wait, so this one doesn't move,
Yeah.
and this one does move.
Yes.
So one you're holding still, and one.
Yeah, they're both at rest initially, but I only accelerated one down vertically after. So they both started off at rest, but I only accelerated one down. Which one would you say that one is?
Are you talking between the apple and the?
No, the whole bottle.
Oh, the whole.
I was
bottle.
holding the whole bottle. They were both at rest initially, but I only accelerated one down vertically.
Wait, can I just ask? Let's say, so if I'm picking this one, am I
Yes.
saying the helium has gone down
Yes.
with the bottle, and then the steel has gone up?
Yes.
Oh, it would have. It's that one.
Yes.
then. Yeah.
Exactly. Because the steel ball's being left behind,
Yeah.
and the whole container's moving down.
Yeah.
And then the buoyant object got pushed down as well. Yeah. So that one I got physically accelerated down.
Yeah.
So let me ask you guys this: if I was holding it like this at rest and I just released it into free fall, do you guys believe gravity pulled it down? In other words, do you think gravity accelerated the whole bottle down?
Yeah, of course.
Yeah, right? Obviously. So the one on the left, the one that didn't show any reaction, that one's actually free fall. But we see that matter didn't react to the acceleration whatsoever. I don't know if you guys knew.
Is it because it's staying at the same speed?
No, because obviously they're in free fall. They're claiming a 9.8 meters per second acceleration.
Yeah.
But I don't know if you guys knew, gravity is just a theory. So a pulling force of gravity has never been actually detected or measured in reality. So,
Okay.
So what's happening, right? So again, if we understand buoyancy always follows the direction of the force, if I have a helium balloon here on Earth and I release it, what direction does it go? Yes. Where do you think it goes up?
Because it's less dense than air.
Yes. So in this example, the container of the truck, obviously, is what generated the force to be able to push the air in this direction, and in the result, that was able to push the helium in that same direction. What's generating the force here on Earth to be able to push the air up, so that it is then able to push the helium balloon up as well?
Is it the air particles going underneath it?
Yeah, you could say it's the air particles underneath pushing the helium up,
Yeah.
because air is more dense, obviously.
Yeah.
But what's pushing up the air, do you think, to be able to push up the helium? Because air cannot move itself.
Ah.
Obviously, right? In this scenario, it was the truck that moved the air, that moved the helium. What's moving the air here on Earth to be able to move up the helium?
Isn't it just the helium moving up? No.
No, it's a direct correlation with the air. It's the air being more dense. Because if you have a vacuum and you remove the air, the helium doesn't rise, it falls. So it's the air being more dense that's able to push it up.
Yeah.
Yeah. So the reality is, it's the Earth that's pushing up against you right now and not pulling you down. Here, last one. I did a vertical acceleration. So again, matter always reacts to acceleration, right? So I had a water bottle with a ping pong ball and a steel ball like this, and I only accelerated one of them down vertically. Which one of these two did I accelerate down from being at rest? The one on the left or the one on the right? Yes, the one on the right. Obviously, because it shows a change, it reacts to a force. So let me ask you guys this: if I'm holding a bottle like this, for example, and it's at rest, and I release it into free fall, do you believe gravity pulled it down to the earth?
Gravity pulled it down.
Yeah, do you think gravity accelerated the bottle down to the earth, right? So here's the thing: the one on the left was actually free fall, but we see that matter didn't react to that acceleration. So I don't know if you guys knew, gravity is just the theory. So a physical downwards acceleration of matter has never been detected, because matter doesn't react to a force in free fall. And that's why Einstein came up with his theory of relativity, because there is no force in free fall. It's the bending and warping of space-time. Right? That's what Einstein came up with, because there is no physical downwards acceleration in free fall. But if we understand buoyancy follows the direction of the force, right? If I have a helium balloon here on Earth and I release it, what direction does it go? Yes. Why do you think it goes up?
Atmospheric pressure.
Atmospheric pressure, exactly. So air is more dense than helium, so it's able to push it up, right? So in this scenario, the truck is what generated the force or the pressure to push the air in this direction, would then push the helium in that direction. What's generating the force here on Earth to be able to push up the air, to be able to push up the helium?
Push up the helium.
Yeah, because the air is being pushed up, the helium's being pushed up by the air, right? The helium balloon, because it's less dense.
Yeah.
But in this scenario, obviously it was the truck that pushed the air to push the helium. Here on Earth, what's pushing up the air to be able to push up the helium?
I mean, technically normal force. Right?
The normal force, okay, exactly. So here's the thing. So the normal force is an upward push of the Earth, and that's a real force that can be measured. In free fall, there is no measurable force. So what's happening in free fall, because objects don't accelerate down towards the Earth, when I release this object, the object doesn't go down towards the Earth. It's the object, it's the Earth that comes up to the object, and that's why this doesn't accelerate down, because it's the Earth that's coming up. So the Earth's force is a push, not a pull. So this whole pulling force of gravity has never been measured or detected. So the Earth is literally moving up through space right now. So the Earth is pushing up against you right now. It's not pulling you down. So, and buoyancy shows us that it's being pushed up, because buoyancy follows the direction of the real force, which they call the normal force, right? But if I have a helium balloon here on Earth and I release it, what direction does it go?
Up.
So obviously we understand helium doesn't move itself. It doesn't. So why does the helium balloon go up?
Basically. Less dense than air.
Yes, so the air is able to push it up. So in this scenario, the truck generated the force to be able to push the air in that direction, which then pushed the helium in that same direction.
Right. Makes sense.
What's generating the force here on Earth to be able to push the air up, to be able to push up the helium?
Gravity.
Yes, gravity. But here's the thing, gravity is not a pulling force of the Earth, it's a pushing force of the Earth. So the ground right now is literally pushing up against you right now, it's not pulling you down, and that pressure is what's creating the air pressure here on Earth, which then is able to push up helium balloons in that same direction. So the air and everything right now is moving up through space right now. So the ground is moving up through space right now. So let me ask you guys this before you go. This is the real reason why I'm doing this. You guys believe the Earth is a ball, right?
Yeah.
If we could prove physically that the ground is pushing up and not pulling us down, and physics shows us that, because buoyancy shows us that, right? If we could prove that the ground is literally moving up through space, obviously you guys understand that up is relative on a ball, right? So if you're standing here, up is this way. If you're standing here, up is this way. Every direction away from the center. So if we could prove that the ground is pushing up and not pulling us down, how can the Earth move up in every direction at the same time if it was a ball?
I don't know.
It actually wouldn't work. That would mean the Earth would have to be
It would just
expanding.
expand,
Yeah,
yeah.
it would just explode. So in order for people to believe in the ball Earth theory, they first have to believe in the theory of gravity being a pulling force. Because if we could prove that it's the other way around, that it's the pushing force of the Earth, then the whole globe Earth concept falls apart.
Yeah.
So it wouldn't even exist on paper.
Yeah.
Exactly. So the reality is the Earth is actually just a level plane extended that's pushing up in one direction. So the Earth is just moving up through space in one direction, and because it's a level surface and we're all standing. So yeah, so that's the number one proof that debunks the globe Earth, is the fact that gravity is a pushing force, not a pulling force. And buoyancy shows us that. So the reality, the force of the Earth is a push, not a pull. And that same pressure right now that's pushing up on you right now, it's just,
We are pushing down.
But isn't that just the reaction force?
Equal and opposite reaction.
so the equal and opposite reaction has to do with inertia. So your body has inertia, so it wants to remain stagnant, it wants to remain static. So the Earth pushing up against that, that's the equal and opposite. Now you have weight because you're resisting that push. So that's why we have weight. So they basically flipped it. Instead of a pulling force and the Earth resists us, it's a pushing force and inertia resists
We're
it.
resisting.
Yes, we're resisting it due to inertia, because our body has mass, and anything that has mass has inertia eventually. And obviously, that's why we have weight. So here's the thing. This is the real reason why I'm doing this. So you guys believe the Earth is a ball, right?
Yes.
Do you guys understand that up is relative on a ball? Right? So if you're
Yeah.
standing here, up will be this way for you,
Yeah.
but if you're standing on here, up is this way, the opposite, right? So if we could prove physically that the ground is literally pushing up and not pulling you down, in other words, the Earth is moving up and not pulling us down, and buoyancy shows us that, right? If we could prove that physically, how can the Earth be moving up in every direction at the same time if it was a ball? How can the Earth move up for you if you're standing here, but and another person down here at the same time?
Like all from the center.
Yeah.
So you're saying the Earth is flat.
So what I'm getting to is that in order for people to believe in the ball Earth, they first have to believe in the theory of gravity being a pulling force. Because if we could prove it's the other way around, then the globe Earth wouldn't work. You know, it would just explode.
But couldn't you just say, like, I mean, you use the situation of a helium balloon rising.
Yes.
That's a fluid.
Yes.
It's rising in the
Yes.
air, but we are being pulled ground, right?
No, so you're more dense than air. Obviously, this ball is
Yeah.
more dense than the air. So air is able to push up a helium balloon because helium is less dense than the air. If something is more dense than the air, then it's just going to be left behind. Just like the apple swinging back, it didn't swing back. It's the container that moved to the apple. So when I released this ball, this didn't move down to the earth. It's the earth that moved up to the object. So everything's moving up right now.
Okay.
And that's why the air is moving up as well, and that's why helium balloons go up.
Okay.
And it's something that's more dense than the air. It only appears to go down because it's the earth that just catches up again. So the earth is literally moving up. And here's the thing. That's the number one proof to debunk the globe earth, the fact that gravity is a push, not a pull.
Yeah.
And the reality is the earth is actually just an extended level plane. So we're all on top of the level plane and it's moving up only in one direction. So everybody's up is the same.
An infinite upward movement.
Some people say that it could be an infinite upward movement, but I say it's probably some kind of cycle. So it's moving in some kind of
saying the earth is flat, or you're saying
it's level.
it's level?
Level. So there's a big difference between flat and level. So let me ask you guys this, because this is what the real reason why I'm doing this. You guys believe the earth is a ball, right?
Yeah.
So do you guys understand that on a ball, up is relative? In other words, if you're standing here, up is in every direction away from the center will be up. If we could prove physically that the ground of the earth is literally moving up through space or pushing up, and that's what buoyancy, that's why we have buoyancy. How can the earth move up in every direction simultaneously if it was a ball?
Well, it's following the trajectory of the sun.
Well, that means it's orbiting the sun. That's what you believe. But if we could prove that it's the ground pushing up and not pulling you down, in other words, the earth is moving up through space, how would that work from a globe earth? If the earth was moving up through space?
Because it's being pulled by a vector from the sun. Because the sun's relative gravitation.
What I'm saying is if you're standing here, up for this person, up will be this way, right? But if you're standing down here, up for this person will be this way.
It has spin.
So how can the earth move up this way and this way at the same time? How can that happen? And in every direction at the...
Spin.
So the reality is it wouldn't work. So in order for people to believe in the ball earth theory, they first have to believe in the pulling force of gravity, which can easily be debunked. Because if we could prove that it's the other way around and it's the earth pushing up, then the whole globe earth model falls apart. So the reality is the earth is actually just a level extended plane that's pushing up on us right now. So everybody's up is the same. So the earth is moving up in one direction, which is up. So that's what gravity is. It's a push, it's the motion of the earth. So the earth is like a giant container and we're inside of it. And the surface is level.
So this is flat earth theory.
No, flat earth is a psyop as well, because over 95% of flat earthers also believe in a pulling force of gravity. They mock it, but ironically they believe the same thing too. So they're morons, I have to say it. Flat earthers are morons. They mock something that they believe as well. But the reality, physics shows that it's the other way around. It's the earth moving up. And that's why this appears to go down, is because everything else is moving up. So this just loses momentum due to inertia, and the earth just catches up again. So that, yes.
If that's what gravity is, then what about like the sun and all the other?
Yeah.
Like,
So when it comes to the luminaries, the sun, the moon, and all of the stars, nobody actually knows what they actually are. So there is a limit to how high human beings have flown, which is about 25 to 30 miles high. And the reason why is because in order to fly, like with a helicopter or an airplane, the air has to be at a certain density to be able to push off of it. The higher you elevate, the less dense the air becomes. So eventually you won't be able to push off of it anymore and gain altitude anymore. So there's a limit to how high we can go, and it's about 25 miles up. Anything that they're telling us about outer space and the stars is all made up. It's just fairy tales. So it's just stories to feed the globe earth concept. So if I was to ask you guys respectfully, what's the number one proof or reason that makes you believe the earth is a ball? Or why do you guys believe it?
Because space. Yeah.
What about space?
The horizon.
Okay, the horizon.
Yeah.
Sure. So because you think like things disappear over the horizon, right? So there is a limit to how far we can see. It's called the limit of perspective. So the horizon is not the curve of the earth, like a physical curve. It's actually just the distance to how far we can see. Put it that way. So because when a boat appears to go over the horizon, and you bring out binoculars or a powerful zoom camera,
You can see the curve. You could see like.
yeah. So
You know what I'm saying?
yeah, here's my thing. Do you know the radius of the Earth?
No.
Just real quick. So here, let me show you the radius. So this is the radius of the Earth, 3,959 miles. So based on the radius of the Earth, there has to be curvature every mile. And using a simple calculation like the Pythagorean theorem, a squared plus b squared equals c squared, we can calculate for how much curvature there should be every mile. And it turns out there should be 8 inches per mile squared. So if there was real physical curvature there, we should be able to physically measure it. So they're claiming that in the first mile is an 8-inch drop, second mile 32 inches, and by the third mile there should be 6 feet of measurable curvature. So how do we measure for that, right? There's a very easy way. Flat Earth is a psyop because over 95% of flat earthers claim the Earth is motionless. So they deny that the Earth is pushing up because they're kind of defending the globe Earth as well. So they're buying into this idea of gravity being a pulling force, but they just claim is something else. So they mock gravity, flat earthers, even though they still believe in something pretty much the same. So it's pretty ironic. So the whole flat earth versus globe earth is a false dichotomy. It's a false debate. It's like Democrats versus Republicans. So it's just, again, it's just there to keep people distracted from the push of the earth. That's the reality. So flat earthers and globe earthers both deny that fact, that the earth is pushing up. And that's what debunks the motionless flat earth and the globe earth.
Okay.
So that's the real truth. You know, if I was to ask you guys respectfully, why do you guys believe the earth is long?
You've got loads of, like, every government, all the scientists, everyone says it's round. For me, it makes more sense that it's round, but then it constantly going up.
But why does it make more sense that it's round? Like, that's the question.
Because
I think that I sort of think like I understand your point, but you can sort of look at the issue in sort of different.
gravity is a force.
Yes, but it's a push, not a pull of the earth.
But
Flat earthers
what
would
if I
deny
say
that.
I believe it's a pull? Because
Well, that's the thing.
It's
Basic.
like a star, like
Yeah.
how stars are made is because all matter is being pulled towards
Yeah.
it. So then that means gravity is pulling things towards it.
Yeah, so here's how we debunk that as well. So not only can we debunk that by the fact that matter doesn't react to acceleration in free fall, we can also debunk it using an accelerometer in our phones. So I don't know if you guys knew, every smartphone has an accelerometer built in, and that's how it's able to detect when you have it in landscape or portrait. You know how it changes?
Okay.
Because it's detecting the vertical force of the Earth. But again, they're claiming that force is down, but it's actually up. It is vertical, but it's up. So it's all just a concept. Reality, physics shows otherwise, that the globe Earth is physically impossible. So if I was to ask you guys respectfully, what's the number one proof that makes you believe the Earth is a ball? Like, why do you guys believe it?
Spherically?
Yes, why do you guys believe the Earth is a sphere?
Why do I believe it's
Yes.
spherical?
Yes.
Well, the horizon dips. There's a refraction of light.
So
Yeah.
the horizon, obviously, there is a limit to how far we can see. So there's a limit to perspective. So the horizon is simply just the limit of our field of view. So anything that goes beyond the horizon is just going out of our field of view. Because when you bring out a powerful
But that
zoom
doesn't work with refraction.
No, well, here's the thing. If a boat disappears over the curve, right, because it's going out of your field of view, if you bring out a powerful zoom camera, optical zoom, and you zoom into that boat, you're able to pop it back into view. Because it has to do with, again, perspective and the limit of vision. That's why boats appear to disappear over a curve, because it's just going out of
So then how can you
perspective.
explain the changing of the sunset with refraction?
Changing of the sunset reflection, what do you mean?
Okay,
Like,
so the sun appears to be white
Yes.
as a luminary,
Yes.
and as it goes down,
Yes.
it moves from orange to then
oh,
pinkish.
yeah.
That is all from refraction.
Yeah. Well, obviously it has to do with the atmosphere as well. I actually don't know exactly how the sun works. Again, nobody knows exactly what it is. They tell us it's a gas ball, but at the end of the day, in my opinion, it's more of like an LED light type of thing. I'm saying that very ignorantly because obviously I don't know what it is, but it's not a fireball.
It's a nuclear fusion.
That's what they say.
No, it is.
But okay, but first of all, when it comes to the sun and the moon and the stars, that tells us nothing about the dimensions of the Earth physically.
Okay.
So that's where it becomes
Appreciate
a red
your time,
herring.
man.
I appreciate it, man. No worries. So here, you guys can take my information.
No, that's cool.
All right, no worries.
Appreciate it.
All right, take care. All right. So if we went out to a giant lake that was miles across, we'll say 3 miles, and we build a level structure above that surface, the body of water, the physics of water when containing at rest is going to show that the surface is always going to be level or parallel to anything horizontal above it. But they're trying to tell us that the surface of water is bending 6 feet in 3 miles and 66 feet in 10 miles, which is a physical impossibility. Water doesn't have the ability to form any shapes on the surface. It always collapses and forms a level surface, regardless of distance. So this will be the number 2 proof to debunk the globe, is the physics of water when containing at rest. It doesn't have the ability to hum.
Gotcha.
So there is no measurable curvature of the Earth. So do you guys have any questions for me before you go?
We have to get to class.
All right.
But thank you.
Yeah,
See
appreciate
you
it,
later.
man. Here, you're my channel. I go to USCLA, UCR. I go
Okay.
to talk about this.
Appreciate it.
All right, man. You guys take care. But here's how we know that.
So you're saying the only reason we fall down to the ground is because we're denser than air?
Yes.
Okay.
Yes.
But
And due to your inertia, your body's inertia.
okay.
Yeah.
But couldn't you also argue it from like a different perspective? Like if you, to be fair, that's just a theory. But again, like how gravity is like a theory, right?
Yes.
And it hasn't necessarily been detected. If you take, for example, like the theory of relativity, and then assume that you have the split of this space-time constant, right?
Sure.
And you know how we're told that the Earth oscillates around the sun, just how
sure.
if you put a bowling ball and then put something, a ball of a slighter mass and roll it around, it will
Right.
start orbiting in a sort of like a.
I mean, they're using a string.
ellipse.
Well, they're using a string in a physical example, but they want us to believe that that's happening without the string, and that's
so do
gravity.
you not believe we're
No. The whole heliocentric model, in other words, the sun being at the center of the universe and we revolve around it or whatever, all of that's made up. So nobody's been outside of the Earth reference frame. Nobody's actually been outside of the Earth reference frame.
Okay.
So yeah, that's the number one proof again. Where gravity is a push, not a pull. You know?
Right.
And again, I mean, do you know the radius of the Earth that they tell us? No? You guys, there's the number two proof that debunks the globe has to do with there is no measurable curvature of the Earth. So
and then the sun going like
what about the sun?
rising, setting, and then like
Well, the sun, again, nobody knows exactly what the sun is, and it just goes out of
Yeah.
view. It just moves. So here's the thing. The radius of the Earth, they tell us, is 3,959 miles. That's
Okay.
the distance from the center to the outer circumference,
Yeah.
right? So based on the radius of the Earth that they tell us, it has to be curvature every mile. So it turns out that there should be 8 inches per mile squared. So in the first mile, it should be an 8-inch drop. Second mile, 32 inches, and by the third mile, it should be 6 feet of curvature. And you can
Okay.
use this formula to verify that, a squared plus b squared equals c squared. You can calculate for the gap between the level and the curve. And again, they're telling us that in 3 miles, there should be 6 feet of curvature. But how do we measure for that, right? Very easy. So if we went out to a giant lake that was 3 miles across with water, and once the water is contained and at rest, if we build a level structure above the surface of water, like completely horizontal,
Yeah.
the water is going to be parallel to anything horizontal above it, because that's the physics of water when contained and at rest. It always collapses towards the level surface. That's what water level means. right?
Okay.
So they're trying to tell us that water level means curve, that there's actually a 6-foot deviation from the level in 3 miles. And in 66 feet in 10 miles, which completely defies the physics of water. So a physical measurement of the Earth has never been done because it doesn't exist. And the
Okay.
physics of water debunks that.
Oh,
So that would be the number 2 proof to debunk the
you
globe.
guys thinking?
You know? So yeah, so if you guys want to take some information, here are the
Okay,
6,
sure.
inside of the 6 proofs that debunk the globe.
Okay,
And I
thank
guess
you.
give it a read. Alright, take care, man.